to the case number 4. Case number 4 is if your f of minus a square is 0, which we discussed earlier. If your f of minus a square is 0, then what happened to this case? So if your f of minus a square is equals to 0, dear students, what happened to this one? Let's have approach. When your f of minus a square is equals to 0, let me write down here two approaches. Okay, f of minus a square is equals to 0, and you have to find out the pi of 1 by fd into sine of ax. Okay, suppose first let's talk about the sine of ax case only. So when we have this one, okay, exactly the question will be like this only now. When it is equals to 0, when you have d square plus a square into sine of ax, yes, definitely. In that case, when you put d square at the place of d square minus a square, it will be 0 only. Yes, exactly. So it can be written in the form of x by 2d into sine of ax. You can write down this approach as a x by 2d into sine of ax, dear students. Now what exactly the meaning of x by 2d into sine of ax? Even 1 by d, as I already told you, 1 by d, it means you have to find out the integration of sine of ax. So more and more you can write down minus x by 2a into cos of ax. Why? Because we know the integration of sine of ax is equals to minus, or integration of sine x is equals to minus cos of x. So we can write down minus x of 2a into cos of 2x. Now you have two approaches. It's your wish whether you want to go with the direct pi. Okay, if you want to write down directly, you can go for this one. If you want to go with the step by step, you can go first this one, then you have to write down this again. Clear, guys? Okay, let me tell you one more time. When we have a case when we have to find out the pi 1 by fd into sine of ax form, then and also f of minus a square is equals to 0. When we have to find out the pi of 1 by fd into sine of ax form, and again when we have f of minus a square is equals to 0, then we will go for this method. Means exactly this case, exactly what I write down here, exactly in this case only f of minus a square is equals to 0. You can see this is the case when f of minus a square is equals to 0. Yes. So when it is equals to 0, what you will do? You will approach x by 2d into sine of ax. Either you can approach like this only, or you can directly approach x by 2d sine of ax, or you can write down it as a x by minus x by 2a into cos of ax. So this is the case when you have a question of sine of ax. Suppose if you have a question of 1 by d square plus a square into cos of ax, so it will become again pi for that, it will become x by 2d into cos of ax only. So you can write down it as x by 2a into sine of ax only, because we have to integrate cos of ax only. So integration of cos of ax is sine of ax by a, so it will be sine ax by a only, right? So this is the pi case when we have f of minus a square. When we have f of minus a square is equals to 0, just remember this one. So these are the two cases possible for sine x and for the cos x. Okay, so we have one example. Let's have discussion on example so that it will be clear in your mind. Okay, so we have one example for this one. Find the pi of the case d square plus 4. Find pi for d square plus 4 in y is equals to sine of 2x. So we have to find out pi for this one. So pi will be 1 by d square plus 4 into sine of 2x only. Yes. So when we approach it 1 by d square plus 4 into sine of 2x, here we can see we have to approach d square we have to write down, we have to replace d square by minus a square. So when we put here d square at the place of minus 4, it will be 0. You can see it will be minus 4 plus 4, which is equals to 0 only. So it's not possible. You can say your f of minus a square is equals to 0 only, guys. Yes, exactly. So what we will approach, we will go for this approach only, as we discussed earlier. Either you can go with x by 2d into sine of 2x, but my suggestion is, dear students, you can approach directly. So you can approach x by 2 into 2 minus cos of 2x. So you can directly write down minus x by 4 into cos of 2x. So my suggestion is that you can go, you should go with this one only. Directly you should go with this one only. It saves the time and unnecessary, there will be no extra repetition. So you should go with this step only. Similarly, in that case also you should go with this step only, right? So when I approach here minus x by 2a cos of 2x, so a is equals to 2 only, so I replaced it. It will be minus x by 4 into cos of 2x, guys. Is it clear to everyone? I think so it's clear to everyone. Okay, so now let's approach to one more example. Let me show you one more example based on this one. So if the question is if the question is find the pi of d square plus 9 into y is equals to cos of 3x. So we can approach again. The pi will be 1 by d square plus 9 into cos of 3x. Clearly seen here, f of minus a square, it means f of 9 is equals to f of minus 9 is equals to 0 only. Yes, exactly. When we approach here minus 9 plus 9, it will be 0. Yes, so we have to leave this one. So it will be 1 by d square plus 9. So it will be you can directly write down x by 2a into sine of ax. We can write down at the place of this one x by 2a into sine of ax. So when we approach it, it will be, dear students, x by 2a. At the place of a, we can write down 2 into 3. It will become sine of cos of 3x will be sine of 3x. Hence we can conclude here, it will become pi is equals to x by 6 into sine of 3x. So that's why it is my suggestion, dear students, we can approach directly with this step only. Okay, it saves the time unnecessary. We will not repeat the things. Okay, so that's why where the question, yeah, that's why when it is cos of 3x, I know very well we can go for this one, x by 2a into sine of ax, right? Here a is equals to 3, so that's why I substitute at the place of a, it's a 3, and we can conclude x by 2 into sine of 3x, right? So in a simple manner we can approach like this, dear students. It's a simple thing to approach. I think you are feeling comfortable with these cases also, right? Now let's approach for the case number next case. So what case we have? The next case is the case number 5. So let's approach to the case number 5, dear students. It's exactly talking about, okay, at the end of these 7 cases, first I will tell you these 7 cases with each and every example. When we conclude these 7 cases, we will have discussion on, as I already told you, this is the case for particular integral only. At the end of this one, we will have discussion on the questions mixed with the CF and PI. Okay, that's why. So let's approach to this one. When we go with this one, the next case is if the pi is of the form of x power m, means when we have as an algebraic function, so we can write down 1 by fd into x to the power m. So it will be 1 by, you can write down here, if you have to find out the pi of 1 by fd into x to the power m. Now it's a special case. Okay, when we have an algebraic equation or algebraic form to approach, how we will approach? We will always convert this into the series. So we will write down, it's 1 by fd will be in the numerator, so it will be fd to the power minus 1 into x to the power m. So it will be your approach each and every time. It will be your approach, guys. I will show you how you can go with the expansions. I will show you how you can go with the expansion, guys. Okay, so how we can expand the things. For that particularly you have to know some expansions. Okay, and actually we already discussed the Taylor series, so although you will not feel difficulty in the expansion of any case, okay, any function, but still I will show you some expansions where which exactly are more frequently used for this particular case. Okay, let me write down the expansions, some expansions for you, few important expansions that you should not miss, few important expansions. Now the first one is what? As I already told you, we have to the question will be in this form only. The question will be in this form only, dear students. 1 by fd into x power m. You will always take fd in the numerator. Okay, so when you take fd in the numerator from the denominator, it will have power minus 1. So it will be fd power minus 1 into x power m always. So when we have fd power minus 1 into x power m, we will approach here expansion. I will show you which type of expansion. So there are few possibilities here. So the first is 1 plus d to the power minus 1. Is it possible? Yes, it can possible. 1 minus d power minus 1, it can possible. The next is 1 plus d power minus 2. The next is 1 minus d power minus 2, and so on. We can make, right? So these 4 or and so on. Similarly, we can have discussion on the so many expansions, but among those expansions, these 4 or 5 are important. So 1 plus d power minus 1, we always have to convert. It means dear students, whatever be the fd we have, we always have to convert that fd in the form of 1 plus d form. We always have to convert this in the form of fd in the form of 1 plus d, then only we can approach these expansion now. Yes, okay, so we have to convert the fd in the form of 1 plus d form always. If there is no fd, if there is no form 1 plus fd, then we have to take common something, then you will take common. Okay, yes, so it will be 1 plus d power minus 1. So the expansion will be 1 minus d plus d square minus d cube, and so on, dear students, right? 1 minus d plus d square minus d cube, and so on up to infinity you can approach. When we have one positive 1 plus d and to the power minus 1, then the sign will be alternative. When we have both the negative things, it will be the 1 minus minus plus d square plus d cube, and so on. It will be up to the infinite term. When we have 1 plus d to the power minus 2, again the sign will be alternate, but it will become 1 minus 2d plus 3d square minus 4d cube, and so on up to the infinite terms again, guys, right? You can write down 1 minus 2d plus 3d square minus 4d cube, and so on infinite. When we have 1 minus d power minus 2, it will be 1 plus 2d, all the terms will be plus only, 3d square plus 4d cube, and so on. It will be infinite. Clear? So we should go for these expansion because it's a compulsion to approach in this particular case. If we have fd, we have to convert that fd in the form of 1 plus d. Either it is possible that 1 plus d power minus 1 will make, or 1 minus d power minus 1 will make, or 1 plus d power minus 2 will make, or 1 minus d power minus 2 will make. Okay, so we have expansion for each and every one. Okay, I will show you an example so it will feel more easy for you. So let me show you an example for particular this question. For this case, find the pi for d square minus 4 into y is equals to what we have? We have x square. So whenever we have this question, you can see this is the form of 1 by fd into x power m only. Yes, exactly. So the pi will be 1 by fd means d square minus 4 into x square only. Yes, as I already told you, whenever we have this form, we have to convert this into 1 plus d or 1 minus d form, right? So we have to make any of these forms. So how we will convert? Let's have discussion. D square minus 4, dear students, I will take minus 4 as a common. When I take minus 4 as a common, it will be 1 plus d square, or I can write down 1 minus d square by 4. Yes, exactly. Minus minus plus it will be, yeah, exactly. So when I take common minus 4 from this one, it will be minus 4, 1 minus d square by 4 into x square is there. So this is the form 1 minus d. Now although we can write down at the place of d it is d square by 4, it's done. We can write down at the place of d the complete will be d square by 4. It's done. So still for me it's 1 minus d form. So we can just shift this form in the numerator. When we shift in the numerator, it will be 1 minus d square power 4 into minus 1 into x square. So we will approach 1 by minus 4, 1 minus d square power 4 minus 1. So we will go for 1 minus d square by 4 power minus 1. We will go with this form only. This is 1 plus d square plus d cube and so on. Here at the place of d we are having d square by 4. So it will be 1 plus d. So d square by 4. My d square by 4 will work as a d only. 1 plus d square by 4. It means d 1 plus d square and so on into x square. Now exactly the meaning of d square is the double differentiation only. D power 4. It will d power 4. D power 4 is nothing but that 4 time differentiation only. Yes, exactly. So we have to differentiate 4 times. As we know very well, we have function x square, so it will not approach for the 4 times. So we can leave the higher terms. Okay. So let's approach. It will be minus 1 by 4. When we approach here, x square will be here. Yes. We have to 1 by 4. We have to double differentiate the x square, and after that it will be 0. Why? Because we cannot differentiate x square as a 4 time. So that's why we can leave here only, guys. Okay, because x square will be, when we differentiate 1 time it will be 2x. When we differentiate 2 time it will be 2. When we differentiate 3 time it will be 0. So that's why 4 time differentiation is not possible. So we can directly write down here the answer will be minus 1 by 4 x square, and the double differentiation of x square will be 2x into 2. So it will be x square plus 2 by 4 only. Yes. So we can write down minus 1 by 4 into x square plus 1 by 2 only. Yes, exactly. So this will be the final answer, my dear students. Is it clear? So although so many of you dear students can think, ma'am, where it is 1 minus d or 1 plus d form. Dear students, we should consider this. It's 1 minus d square by 4. We can consider it's as a 1 minus d square by 4 is nothing but d only. We can consider this as a complete d. Okay, so accordingly we can observe or we can perform. Okay guys, yes, clear to everyone. Now let me show you one more example so that it will be more clear to you guys. Let me write down one more example for this particular case. Find the pi of d cube plus 8y is equals to d cube plus 8y is equals to x to the power 4 plus 2x plus 1. X to the power 4 plus 2x plus 1. Let's approach here. So d cube plus 8 is equals to x to the power 4 plus 2x plus 1. So let's approach here. The pi will be 1 by d cube plus 8 into x to the power 4 plus 2x plus 1 only. Okay. When we approach here again, as I already told you, we have to make it 1 plus d or 1 minus d form. So we will take common d 8 only. It will be 1 plus d cube by 8. Yes. It is x power 4 plus 2x plus 1. Let's take it in the numerator. So 1 by 8, it will be 1 plus d cube by 8 to the power minus 1. Yes. X power 4 plus 2x plus 1 we are having. Yes, exactly. So let's approach it, guys. Let's approach it. So it will be, when we approach, it will be, let me write down here only. It will be 1 by 8. Yes. So this is the expansion of 1 plus d power minus 1. The first expansion, 1 plus d power minus 1 means the sign will be alternate. It will be 1 minus d cube by 8 plus d cube by 8 whole square. I think it's enough. And you have to approach x power 4 plus 2x plus 1 on this one, right? So let's write down here only now. When we approach it, guys, it will become what? When we approach it, it will become 1 by 8 is there only. Yes. When we approach it, it's apply on this one. So it will be x to the power 4 plus 2x plus 1 as it is. Yes. Minus, it will be 1 by 8, the triple derivative of x to the power 4 plus 2x plus 1. Now just look at here. When we differentiate this one, x to the power d cube. So first time it will be 4x square, 4x cube. Second time it will be 4 into 3, 12x square. The third time it will be 24x, and the fourth time it will be 24, right? So after that it will not differentiate, guys. Yes, exactly. So that's why we can leave here only. So we are having as a d cube only. So after the next term will, because it's differentiating 6 times, it's not possible, so we can leave the next term only, so we can leave here. Okay, now let's approach it. It will be 1 by 8 my dear students. It is same, x power 4 plus 2x plus 1 only. Yes, exactly. So so when we approach it, it will be 1 by 8. The first time it will be 4x cube plus 2. Second time when we differentiate, it is 12x square plus 2. And third time when we differentiate, it is 24x only, right? So when we differentiate it third time, it will be 24x guys. So we can write down here the third time it will be 24x. So 1 by 8 x power 4 plus 2x plus 1 minus 24x by 8. Okay, clear? I think you are getting my point. This is the first differentiation, this is the second, and this is the third. We have to differentiate third time only, na, 3 time only. It will be 3. So the answer will be 1 by 8 x to the power 4 minus x plus 1 minus 3x plus 2x. It will be minus x plus 1. Hence this will be my answer. Okay. So if there is power 4 will available, we can go for power 4, but here we don't have power 4 guys, so that's why we can't approach, because here it will be power 6. So 6 times the differentiation will be 0, that we know very well. So that's why we stopped here only, at the third place only we stopped. Clear guys? So this is the form which we have discussion. Okay, on that which we have discussion. It's a basic form to approach. Okay, let me show you one more example so that it's clear to you. Let's have discussion on one more example of the same. Let's have one more example. So after that we are done with the case number 5. So we have only 2 cases, and that are exactly, I will tell you, that are the mixture, exactly the mixtures. So let me show you one more example so that it's clear to you exactly. So we have to find the pi for what? Find the pi of d square plus 2d plus 1. Here we have d square plus 2d plus 1 into y is equals to x square plus x. Let's find the pi for this one. So when we approach this one, the pi will be, the process will be same, 1 by d square plus 2d plus 1 into x square plus x only. We have to make it in the form of 1 plus d. So but here we can see it is nothing but the d plus 1 whole square. Yes, exactly. So it is x square plus x only. When we move it in the numerator, it will be d plus 1 power minus 2 into x square plus x. It means this is the third number form, right? We can go for the form number 3. So the pi will be, according to form number 3, it will be alternate sign, right? So if you want, you can write down it as a 1 plus d power minus 2. Okay, the things are same, although it will be 1 minus d plus d square, 1 minus d plus 1 minus 2d, it's my mistake, 1 minus 2d plus 3d square. Okay, what we have exactly in the function, I think the double derivative is enough. 1 minus 2d plus 3d square, and we have to approach x square plus x. I just not write down here minus 4d cube, because the triple derivative will not exist for the function x square plus x. That's why we can leave the triple derivative. Okay, so let's approach it on each and every function. When we approach it, it will be, dear students, x square plus x, yes, minus it will be 2 into differentiation, one time differentiation of x square plus x, plus 3 into double differentiation of x square plus x, yes. When we approach it, it will be x square plus x minus 2 into differentiation, one time differentiation, it will be 2x plus 1 only, plus 3 into, when we differentiate one time, it will be 2x plus 1. We have to differentiate it one more time, it will be 2 only, guys. Yes, exactly. So we can write down here x square plus x minus 4x minus 2 plus 6. So hence it is x square minus 3x plus 4, dear students. So this will be your final pi. This will be your final pi. Is it clear? So we can approach just like this. So these are the 5 cases which we discussed, and in the next we will have discussion on the case number 6 and case number 7. Okay guys, so case number 6 and case number 7 are ultimately the mixtures, the functions which are having mixture. Okay, let me show you the cases, then we will have discussion on the questions based on this later. So the find the pi of the form, whenever we have the pi, we have to find the pi in this form, means when we have 1 by fd into e to the power ax into v. So e to the power ax is, we know that the exponential function, where v can be, v is the function of x or trigonometric, e power ax is the exponential function only. But when we talk about the v, your v can be a function of x, means algebraic function or a trigonometric function. So when it happen, so for v we have two choices, it can be trigonometric function or it can be algebraic function, means in the form of x only. So when we have two choices, when we have two functions together, okay, it's e power ax into v. When we have two functions together, the fpi will be, we have to write down e power ax separately, then we will approach at the place of v, we will write down 1 by f of d plus a, guys, right? At the place of d, we will write down 1 by f of d plus a into v. So this will be the approach. So as I already told you, these case number 6 and case number 7 are exactly different, because here we will have always two terms. So you have to remember these two forms exactly. We don't have any shortcut for these forms. So what exactly you have to do, you can remember just like this, 1 by fd into e to the power ax into v. We have to just separate e power ax, then on the d we will write down d plus a. At the place of d we will write down d plus a, then we approached v, okay, right? And the form number 7 is what? Form number 7 is 1 by fd. When we have a question in the form of 1 by fd into xv, now here we can see the x is fixed, which is algebraic, and v is the function of exponential or trigonometric. So I will suggest when you have to go with the form number 7, you can leave this form, because you can approach the same form with the help of 6 only, because 6 is the same thing again. When you have an algebraic and an exponential function, you can go for this one also. When you have a trigonometric and exponential function, again you can go with this one also, right? So at the place of case number 7, you can use directly case number 6. So you can leave this one also, but although I will tell you the method, I will tell you the formula, because here there is not at all any shortcut. You have to remember, my dear students, there is not at all any shortcut for this one, okay? So xv we can leave here, we can approach. X will be in the side, it will be 1 by fd into v, minus we have to differentiate d, it is f dash d divided by fd whole square into v. So it's quite difficult to learn. The form number 7 is exactly quite difficult to learn. So that's why I am approaching, because in this form also x is fixed, right? Either we have v in the form of v, either we have e to the power ax, or we have sine or cos, means, or we have trigonometric function. So when we have sine or cos with the algebraic function, we can go for form number this one also. Yes, exactly. Or when we have exponential with the form of with the x form, we can go for form number 6 also. So I will suggest at the place of 7, you can go for case number 6. But it's again up to your choice. I told you the formula and there is no choice. You have to remember only. Exactly, to be frankly, dear students, there is no choice, because we have to remember this formula only. Okay.